Hi guys, what is up? Welcome to my channel, and in this video we are going to solve the question in physics on B3. This is science paper 1, and 2023 GCE. Okay, so let's check out this question. So this question is this one, question B3. So as you can see, the figure B3.1 shows the direction of four forces acting on a car whose weight is 8,000 newtons. As it travels in a horizontal straight line, okay, so you can see that we have four different forces as indicated by the arrows. We have force B on your left, we have force A upward, we have also force C downward, and force D on your right. So now they're saying which two forces should be equal for the car to move at constant velocity. Okay, so you can see that we have force A, C, D, B. Now, for you to answer this question, you have to understand that as the car is moving in the horizontal, so this is the ground, let's say this is a tarmac, and let's say this is a vehicle. So the upward force and the downward force does not affect the movement, okay, but this force going that, and then also that force going that direction. So what that means is that this force B and force D must be equal, so that the vehicle, this car, can move at a constant velocity. So in this case, your answer is just force B and force D. So these are the two forces that need to be equal. Okay, so what is the next question? So now we have been given B. There is a table there that we must be able to pay attention to. The following table, B3.1, shows sizes of forces acting on the same car after it had covered a certain distance. Now take G as 10 Newton per kg, and for your own information, G means acceleration due to gravity. Now they are saying calculate the mass of the car, and this just requires you carries 1 mark. Okay, so we know that you have to correct the information. So we are looking for the mass, which we can just say question mark, we don't have. And what we know that we also need the weight. So if you go back to the question, you discover that just from this statement where it says figure B3.1 shows the direction of four forces acting on a car whose weight is 8,000. So the weight of the car is 8,000. So this is 8,000. Now we know that gravity, which is G, G is 10 Newton per kg. Okay, so therefore we know that the weight of an object is equal to mass multiplied by its gravity. So we are looking for M. So what we are going to do is just make M the subject of the formula by dividing both sides by G, both sides by G. So what happens? G goes. So therefore, we're going to have M equals to W divided by G. And we know that the weight of the car is 8,000 Newton. divide by 10 Newton per kg. So then this is just going to be the n goes. Remember, we are looking for the mass, so also this 0 goes and this 0 goes, so just remain with 800 kg. So that is how you go about answering that question. Then next question is about finding the resultant force on the car. Now, when you're looking at the resultant force, just from this table, you can see that force A down there, it is 800. Force B down there, it is 1000. Force C, it is 8000. And force D, it's 600. So the forces that are causing the movement in terms of the vehicle, which is moving in the horizontal way. So just to repeat that again. So what you're saying is that this is the vehicle. We are just going to assume that. So there is a force there, which is force D. And then there is another force, force B. Okay. Now, we know that force B, we have the value, and force D, we have the value. Now, these are the two forces that are causing movement. Now, and you can see that these two forces are going in different direction. Force B is in a left direction. So when you look at the X or Y graph, is that on this side of the X-axis, for example, we have positive numbers. And then on the left side of the X-axis, we have negative numbers. So assuming that this is the center, this acts as a center. So whatever is going on your left is negative force, whatever is on the right is positive force. So what that means is that then we can now say that resultant force, where R means resultant, is it going to be negative force of B plus force D. Okay. Now we know from the diagram that, from the table, that force B is 1000. So we are going to have negative 1000 plus, and also force D, that's 600. You can see there, force D there on the far column there. That's 600 down there. And this is going to be plus 600. So we are going to say negative 1000 plus 600. Okay, so using our calculator now, we can use our calculator. We have negative 1000 plus 600. So we are going to have negative 400. So which tells you to say the vehicle is moving on the left in the negative direction. So this gives us resultant force is equal to negative 400 Newton. Remember that a force is a vector quantity, so it can either be positive or negative. Okay, so moving on. The last question now, they're saying find the acceleration of the car. So now, based on the resultant force, we can find now the acceleration of the car. So we know that the relationship between force, mass, and acceleration is that force, meaning the resultant force, equals to mass times acceleration. Now we know that our mass was 800 kg, and our acceleration is what we are looking for, and our resultant force is negative 400. So this implies that resultant force is just going to replace accordingly. So replace accordingly. Where there is this, we're going to put negative 400 equals, where there is mass, we are going to put 800. And then since we don't know acceleration, that's what we're looking for, this is just going to remain A. So then we are going to now divide both sides. We're going to divide both sides by 800, then also 800. Okay, and this goes, and 800 is your calculator now. This implies that negative 400 divided by 800. So we just get to negative 0.5. So we are going to have our answers are negative 0.5 meter per second squared. So that's our answer. So that's how you can go about solving this question that came in GCE Science Paper 1, which is physics. So thank you so much for watching. Please like my video, share, and also subscribe to my channel. Thank you so much.